Hello. So in this video, we are going to be looking at the analytic view of absolute values, the idea of how we would make numbers positive, right, in some algebraic way. So typically when we're looking at absolute value, the process of actually sort of computing an absolute value can be straightforward if we know what's inside the absolute value. And turns out if is a very important word in that statement, right? So normally if we want to do something like evaluate f of 2, well, we plug in 2 and then we compute the inside, right? So we would plug in our 2 on both sides, then we would compute this inside bit and say, okay, well, we have the absolute value of 4 minus 1, that's the absolute value of 3, but 3 is already positive, so we do nothing, right? And then we can just put it together, we get 10. Cool. If we want to do something like f of negative 2, we plug in negative 2, that gives us absolute value of negative 5. Well, we know it makes it positive, right? So we just flip the sign and make that into a positive 5. Now we have 5 plus 7. We can evaluate that as 12. Cool. Problem is what if we don't have a number, right? Like what if we need to leave it in terms of x? Then what do we do? Because with the numbers, we can sort of compute it down and get a very concrete value, 3 or negative 5, and be like, okay, that's positive or that's negative. But with variables, we don't know if the variable is positive or negative. So what do we do? Well, in that case, we have to do a little bit of work first. So we start by determining when the content inside the absolute value is going to do something. So we take what's inside the absolute value, right? This 2x minus 1, the part that's inside, and we set it greater than or equal to 0. We're doing this because the idea is if it's greater than or equal to 0, that tells us that whatever's inside, that for those values of x, that thing is going to be non-negative, so nothing's going to happen, right? So we can solve for those x values. So we move the 1 over, we divide by 2. This tells us when x is greater than or equal to 1/2, the absolute value is going to do nothing, because in particular, when it's greater than or equal to 1/2, that means that if we plug in any of those numbers, 1, 2, 5, pi, this entire inside is going to be positive, so the absolute value isn't going to do anything. Likewise, we would go through the same process, but we'd end up getting x less than 1/2. Here, when x is less than 1/2, we have the opposite, meaning that when x is less than 1/2, the absolute value needs to, quote unquote, flip the sign. Because if we pick something smaller, say 0, when we plug in 0, we're going to get a negative, right? That's what this is accomplishing right here, is we're figuring out which x values have sort of positive end results inside the absolute value, and thus the absolute value doesn't do anything, and which ones have negative results inside, in which case the absolute value needs to somehow flip that sign. As a sort of footnote here, I will mention that which one gets the equality doesn't actually matter in this case. And the reason why is because when it actually equals 1/2, if we plug it in, we get 2 times 1/2 is 1, 1 minus 1 is 0, absolute value of 0 is 0, sort of 0 is not positive or negative. So here we attach the or equals to the greater than 0, but we could have just as easily attached it to the other side as well. Either one is fine. Okay. So now we're at the point where we're like, okay, we know when we need to do nothing with the absolute value. And we know when the absolute value needs to flip the sign, but how do you, quote unquote, flip that sign, right? How do you make it from negative to positive? And the key idea here is that in order to make something negative into something positive, the best way to do that is to multiply by -1, right? So if we had -5, like we did down here, then to remove the negative, we would just multiply by -1, -1 times -5, +5, that gets rid of the negative for us. Finally, we're going to rewrite our absolute value by splitting into these two cases, meaning we're going to split it into the situation where x is greater than or equal to 1/2 and where x is less than 1/2. But if that's hopefully pinging a thought in your head right now, that means that we're going to be using piecewise functions. Right? So we would rewrite this as the piecewise function, where we have the function, right, the absolute value 2x minus 1 plus 7, when x is less than 1/2 versus when x is greater than or equal to 1/2. But now, because we split it up, when x is less than 1/2, then we know that the absolute value is going to need to flip the sign by multiplying by -1. Whereas when it's greater than 1/2, the absolute value does nothing, so we can basically just get rid of it and replace it with parentheses. So we can take the absolute value, break it into this piecewise function, and then rewrite the inside of that piecewise function to reflect this idea of we know now when it's going to have a positive interior, and we know when it's going to have a negative interior, and we know how to turn that negative into a positive by multiplying by -1. So that's what we did in this top part here, right? We replace the absolute value with parentheses, and then we multiply by -1, and then we can simplify. And that gives us that the equivalent function for this absolute value, this thing here, is equivalent to our absolute value, where we have -2x plus 8 when x is less than 1/2, and 2x plus 6 when x is greater than or equal to 1/2. Again, because we've now split up the situation where when x is less than 1/2, we've identified that's when the inside is negative, so that's when the absolute value is going to do something. And when x is greater than or equal to 1/2, that's when the absolute value, the inside is positive or 0. So it's when it doesn't do anything. We can just get rid of the absolute value, replace them with parentheses. Okay? All right, so what do we do? Well, we went through the sort of analytic view of absolute value, this idea of if we're given an absolute value, we can identify when the inside is positive or negative, break it into a piecewise function, and on the domains where the piecewise function, where the absolute value is negative, we take that function bit and we multiply by -1, turning the absolute value into parentheses, because that's how it makes it positive, right? In the other spots where the inside's already positive or 0, we would then just replace the absolute value with parentheses because they don't do anything, right? They don't change the sign if it's already positive. And that allows us to turn this absolute value where we're not really sure what is going to happen unless we actually have a number to use. We can turn it into a different kind of function where it's very clear which type is sort of applied at which time, right? Whether it's positive on the inside or negative on the inside. Okay, so that is that.